Okay, let's get right into it. Today, we're tackling a huge topic: artificial intelligence making one of the most difficult decisions imaginable. Who gets a life-saving organ transplant and who has to wait? This is where programming meets morality, and we're going to break down exactly how that works.
But seriously, just stop and think about that for a second. If you had to decide, what would your rules be? Who gets priority? The sickest person? The youngest? The one with the best odds of a full recovery? How could you ever be sure that your own personal biases weren't creeping in? It is a massive ethical puzzle.
So, to try and solve this very puzzle, the UK's National Health Service turned to tech. They built an algorithm called ANOLOS, and the idea, on paper, was brilliant. Let a machine apply the exact same rules to every single patient. That way, you could remove all the messiness of human error or prejudice. The goal was simple: pure consistency. But as we're about to find out, being consistent isn't always the same thing as being fair. And to really understand what went wrong here, we have to look past the ones and zeros and get to a very real human story. Meet Sarah Meredith. She was just 31 years old, and their liver was failing. She did everything she was supposed to do. She got into the system, she was placed on the official national transplant list, and all she could do was wait and hope for that one phone call that would literally save her life. But that call never came. For more than 2 years, she waited. And as the weeks stretched into months and months into years, Sarah just kept getting sicker. Her life was hanging in the balance, and the very system designed to save her seemed to be looking right past her. So that's the big mystery we need to solve. She was in the system, her condition was getting worse, so what was the algorithm seeing? Or maybe more importantly, what was it not seeing? To figure that out, we have to understand the different rulebooks an AI can use to even define what fairness is. Yeah, it turns out fairness isn't just one thing. There are two big ways AI thinks about it, and you know what? Sometimes they completely contradict each other. Let's break them down. So look at this. On one side, you have individual fairness. The best way to think about this is like a referee in a soccer match. The ref applies the exact same rulebook to every single player no matter what. A foul is a foul. On the other side, you've got group fairness. This is more like a sports analyst who looks at the stats for the entire season and says, hey, wait a minute, does this one team get way more penalties called against them than anyone else? One focuses on the single action, the other zooms out to see the bigger pattern. So yeah, individual fairness is all about that one-to-one consistency. The core idea is simple. If two people are similar in all the ways that matter for a decision, they should get a similar outcome. It's like a teacher grading a stack of tests with the exact same answer key for everyone. This is precisely what the UK's transplant algorithm was designed to do. Group fairness, though, takes that super wide-angle view. It's not worried about one specific decision. It looks at all the decisions and asks, are the results balanced? For instance, are transplant rates fair between different age groups or different genders when you account for their level of need? It's not about the single call, it's about the pattern of all the calls together. And right here is where it gets really, really tricky. What happens when an algorithm tries so hard to be fair to every individual that it accidentally creates a system that's deeply unfair to an entire group of people? Okay, so the UK algorithm was all about individual fairness. It would take a bunch of health data from a patient and crunch it all down into one number, a transplant benefit score. This score is basically a similarity metric. It's how the machine decides which patients are most alike in terms of their need. The person with the highest score, they get the next available liver. It sounds totally objective, right? But there was a huge problem hidden inside that metric. And that problem has a name: algorithmic bias. In this case, a human assumption got baked right into the math. And what was it? An age penalty. The system was programmed with the belief that younger patients are just naturally tougher and can wait longer for an organ. So while trying to be individually fair, the algorithm consistently and systematically gave younger patients, like Sarah, a lower score, no matter how sick they actually were. And this chart, wow, it just shows you the devastating result. Before the algorithm, the difference in wait times between younger and older patients was about 40 days. Not perfect, but okay. After the algorithm took over, that gap exploded to 156 days. The very attempt at individual fairness, applying that same flawed rule to everyone, created a massive case of group unfairness. You know, for Sarah and her family, the worst part was that this was all happening inside a black box.
They had no idea why she kept getting passed over. As Sarah herself said, the transparency needs to be there. And she's right. You should be able to understand the rules of a system, especially when your life is on the line. So if a system built on this simple idea of fairness, just treat everyone the same, can fail so badly, what's the fix? Well, we have to introduce a new and honestly much smarter concept, equity. I'm sure you've seen this image before, and it is perfect for this. Equality is giving everyone the exact same box to stand on to see over a fence. Everyone gets the same treatment. But equity is about giving each person the specific size box they need so that everyone can actually see the game. It's not about giving everyone the same thing, it's about making sure everyone gets a fair shot at the same outcome. And that's the key takeaway. Equity gets that a one-size-fits-all rule doesn't work if people aren't all starting from the same place. An equitable algorithm wouldn't have just blindly applied that age penalty to Sarah. It would have been smart enough to recognize that the rule itself puts her at a huge disadvantage and then correct for it. It's the step beyond simple fairness. It's about aiming for actual justice in the final results. This whole story raises a massive final question. Even if we get better at building these equitable algorithms, should a machine, a piece of code, ever get the absolute final say when a human life is at stake? And this is where a critical safety feature comes into play. It's called an override. Think of it as a human in the loop, a doctor or a review board that has the power to step in and say, hang on, the numbers here don't tell the full story. It's a check and balance on the machine's power, especially for those unique cases like Sarah's that the algorithm just wasn't built to handle. And when you ask people what they think about this, well, the answer is pretty clear. A recent study found that almost 90% of us think a human committee should absolutely have the power to overrule an AI's decision. It seems like we want the speed and consistency of the machine, but we still trust the wisdom and, frankly, the compassion of a human expert. And that leaves us right here with this last big thought. When a system is designed to be fair, and it is perfectly consistent, but it's consistent at being unfair, who's responsible? Is it the programmer who wrote that biased rule? The hospital that deployed the tool without checking it properly? Or is the code itself somehow to blame? There are no easy answers here, but asking these tough questions is the only way we're going to build a future where our amazing technology actually serves our deepest human values.